Hi everyone, welcome back to our channel Light to Crack Maths. So in today's video we are going to see about the concept of properties of rational numbers. So first we are going to focus on the properties of addition of rational numbers. So before we move on to the video, if you are a first time viewer of the channel, please do not forget to subscribe our channel and click on the bell icon to get notification of our future videos. So if you want to know what we had done in the previous video, I'm just sharing the link of the previous video in the description. Just have a look at it. So now moving on to the very first property, the closure property. So to explain this, I will take an example. So let us take two rational numbers a by b and c by d. So let our a by b equal to 1 by 2 and our c by d be equal to 3 by 4. So since this is properties of addition of rational numbers, what we are going to do is we are going to just add a by b plus c by d. So when I am adding, that is nothing but 1 by 2 plus 3 by 4. So the denominators are different. So you will have to take the LCM. So LCM of 2 and 4 is nothing but 4. So we are multiplying this 2 and 1 by 2. So we get 2 by 4 plus 3 by 4. So our answer is 5 by 4. So 5 by 4 is of the form P by Q, where Q is not equal to 0, which implies 5 by 4 is a rational number, right? So you can come to the conclusion that addition of rational numbers are closed, right? So the second property which we are going to check is the commutative property. So what does commutative property mean? If we are going to take two rational numbers a by b and c by d, and we are going to add them, a by b plus c by d should be equal to c by d plus a by b. So now let's check if this is holding good. 1 by 2 is going to be my a by b and my c by d is equal to 3 by 4. So again into 2 is nothing but 2 by 4 plus 3 by 4, which is again equal to 5 by 4. So now we'll check the other way round. 3 by 4 plus 1 by 2. So again the LCM is 4. So you have 3 by 4 plus 2 by 4. So 3 plus 2 is 5 by 4. So here it is very clear that our a by b plus c by d is equal to c by d plus a by b, which means commutative property holds good for addition of rational numbers. So the third property is associative property. So associative property states that for any three rational numbers a by b, c by d and e by f, we have a by b plus c by d plus e by f is equal to a by b plus c by d plus e by f. So that is, while adding three or more rational numbers, they can be grouped in any order. So even if the order is going to change, you are going to get the same sum. So now let's see this with an example. We have 1 by 2 plus minus 1 by 3 plus 1 by 5. So now if you are going to add this, try to add this, what do you get? 1 by 2, plus into minus is minus, so minus 1 by 3 plus 1 by 5. So now if you are going to take LCM, then it's 3 minus 2 by 6 plus 1 by 5. So this is nothing but 1 by 6 plus 1 by 5. So again, if we are going to take LCM, it's going to be 5 plus 6 by 30. So that is nothing but 11 by 30. And then moving on to the right hand side, so you get 1 by 2 plus minus 1 by 3 plus 1 by 5. So here you will have to take LCM for 3 and 5. So it is 15. So minus 5 plus 3 by 15. So minus 5 plus 3 is nothing but minus 2. Minus 2 by 15. So reason why we get minus 2 is when you have two integers with different signs, you will have to subtract and write the sign of the greatest number. So the sign of the greatest number here is minus, right? So we are getting minus 2 by 15. So now again plus into minus we have. So plus into minus is minus 2 by 15. So the LCM of 2 and 15 is 30. So we have 15 minus 4 by 30, which is again equal to 11 by 30. So from this example, you can see, like, even when the orders of the rational numbers are changed, we are getting the same sum. So associative property holds good for addition of rational numbers. The fourth property which we are going to review is property of 0. So property of 0 states that the sum of any rational number and 0 is the rational number itself. That is, if a by b is any rational number, then a by b plus 0 is equal to 0 plus a by b, which is again equal to a by b. So you can take any example for this. So let us take an example of 4 by 5 plus 0. So any number added to 0, you get the same number. Or if 0 is added to any number also, we get the same number as the sum. So property of 0 also holds good for addition of rational numbers. So the final property which we are going to discuss is negative of a rational numbers. If a by b is a rational number, then minus a by b is a rational number such that a by b plus minus a by b is equal to minus a by b plus a by b, which is equal to 0. So minus a by b is called the negative of a by b, and it is also called the additive inverse. What is it called? It is called the additive inverse. So based on this property, we have two other results which are important for us to remember. Minus a by b is the negative of a by b. Then a by b is the negative of minus a by b. That is, a by b is equal to minus of minus a by b, which is again equal to a by b. Okay, so this is the very first rule, which is an implication of property 5. And the second result is 0 is the only rational number which is its own additive inverse. So the additive inverse of 0 is 0 itself. So now we come to the conclusion of properties of addition of rational numbers. So the next is properties of subtraction of rational numbers. So again, for properties of subtraction also, we start with the closure property. So let us consider two rational numbers a by b and c by d. So if we are going to subtract these two rational numbers, the difference which we get should also be a rational number. So let's check it. Let us consider our a by b to be equal to 4 by 5 and our c by d to be equal to 3 by 10. So now a by b minus c by d is equal to 4 by 5 minus 3 by 10. So the LCM of 5 and 10 is 10. So you have 4 into 2 by 5 into 2 minus 3 by 10. So it is nothing but 8 by 10 minus 3 by 10. So our answer is 8 minus 3 by 10, which is equal to 5 by 10. 5 by 10 is of the form P by Q, where Q is not equal to 0. Hence this difference satisfies the condition of a rational number. So closure property is true for subtraction of rational numbers as well. So now we are going to check the commutative property for subtraction. So what is commutative property? Our a by b minus c by d should be equal to c by d minus a by b. This is commutative property, but we are going to see if it is going to hold good or not. Okay, so we'll take a simple example where our a by b is equal to 3 by 4 and our c by d is equal to minus 1 by 4. So 3 by 4 minus 1 by 4, the denominators are the same. So you needn't take an LCM and you can start the subtraction directly. So 3 minus 1 by 4, that is nothing but 2 by 4. So now we'll check it the other way around. 1 by 4 minus 3 by 4. So again, this can be written as 1 minus 3 by 4. So you have two integers with different signs, which means you will have to go in for subtraction. So 3 minus 1 is 2 and you will put the sign of the greatest number. So here, while comparing 1 and 3, 3 is our greatest number. Since it is having a minus sign in front of it, the answer will also have a minus sign. So the answer which we get here is minus 2 by 4. So we see that our a by b minus c by d is actually not equal to c by d minus a by b. So commutative property does not hold good. Does not hold good for subtraction of rational numbers. Okay. So now we'll move on to the next property. The third property which we are going to check is the associative property. So associative property is nothing but a by b minus c by d minus e by f. So this is one order of group and the other could be a by b minus c by d minus e by f. So for addition, it is holding good. So for subtraction, let us see if it is going to hold good or not. So that is why I didn't use the equal to sign yet. So now we'll take an example where our a by b is going to be 3 by 4 and our c by d is 1 by 4 and our e by f is minus 2 by 4. Okay. So according to board mass, we'll have to complete or break down the bracket first, right? So this is nothing but 1 minus 2 by 4. So again 3 by 4 minus of minus 1 by 4. Minus into minus is plus. So you get 3 by 4 plus 1 by 4. So this is nothing but 3 plus 1 by 4, which is 4 by 4. So now let's check this one. 3 by 4 minus 1 by 4 minus 2 by 4. So again, according to board mass, bracket should be broken down. So we have 3 minus 1 by 4 minus 2 by 4. 3 minus 1 by 4 is nothing but 2 by 4 minus 2 by 4. So this is equal to 0. 4 by 4 is not equal to 0. Hence, associative property also does not hold good for subtraction of rational numbers. So now we are going to check the fourth property. So the property 4 is existence of right identity. In case of addition, we have a by b plus 0 to be equal to 0 plus a by b, which is again equal to a by b. But in case of subtraction, for any rational number a by b minus 0 will be equal to a by b, whereas 0 minus a by b will be equal to minus a by b. This is not equal to our a by b. That is why we tell only the right identity exists for subtraction. Okay, so we are done with the properties of subtraction of rational numbers. So to wrap up this video, we have seen properties of addition and properties of subtraction of rational numbers in this video. So if you like this video and if this video was really informative, then just like and subscribe our channel, and you can share about our channel to your friends so that they can also use the light to crack their math. Until next time, take care. Bye bye.